This lecture is about data visualization concepts. We will explore this with the help of 6 plots. This lecture is without any code and has only concepts. So please feel free to watch it. What is the talk outline? We will discuss a scatter plot with regression, distribution plot which is an histogram, box plot, bar plot and a correlation map. The greatest value of a picture is when it forces us to notice what we never expected to see. Wonderful statement by none other than John Tukey, mathematician and statistician best known for fast Fourier transform and box plot, which we will also study. The box plot we'll study in this session. Scatter plot has the points that show the relationship between two continuous variables. So what is a continuous variable? A variable which is not discrete, meaning it has a number within a range, it has infinite number of values, like a square feet and the price. As the square feet is increasing, we see the price is also more or less increasing. The scatter plot gives us a very good indication of that. In the subsequent lectures that would follow, we would actually construct the scatter plot with Python. Next is a scatter plot with the regression line, the same one, but here what we are showing is that we are fitting a regression line, a straight line along the points. So it's the same as a scatter plot, but the addition is the line which shows the relationship between square feet and price, and we can see very clearly of how the price is increasing with the square feet. What is a histogram? The histogram examines the distribution of a continuous variable. To construct a histogram, the first step is to bin the range of values, that is, divide the entire range of values into a series of intervals, and then count how many values fall into each interval. So here what we are doing is that we are dividing it into several intervals, and within each interval how many values are falling in, that is what we are showing. The bins are usually specified as consecutive, non-overlapping intervals of a variable. The bins must be adjacent and are often but not required to be of equal size. So this is an histogram. Before we jump on to the box plot, we revisit the percentile concept. The pth percentile of a group of members is that value below which lie p% of the numbers in the group. So if it is the 50th percentile, then the value below which lie 50% of the values. If it is a 25th percentile, it is that value, say a number, say it is 70, below which lie 25% of the numbers in the group. So the box plot is a very interesting plot. It has got a couple of points. It has got this middle line which is a median, which is the 50th percentile, and it is bounded by the 25th percentile and the 75th percentile. Then there are two whiskers. So these whiskers, this whisker is a quartile 1, that is the 25th percentile minus 1.5 times the interquartile range, that is the difference between the 75th percentile and the 25th percentile, and the other end point, that is the other whisker, which is the third quartile, which is the 75th percentile plus 1.5 times the interquartile range. But there are certain values which are lying outside this, which are the potential outliers. And these, what are the potential outliers? These potential outliers are those which are beyond this point, which is quartile 1 minus 1.5 times the interquartile range, and the other one which is the third quartile plus the 1.5 times the interquartile range. So you will have you can see that it is very easy to find this type of outliers in a very easy way. So here we see another plot, and here what we have done is that we have plotted the house prices based on suburbs, and these are some of the suburbs in Melbourne, and very good suburbs in Melbourne. See, for example, if you see Canterbury, the median price is quite high, and then you can find maybe Malvern, which is also a great suburb, and this also has a very high median price. So what are the lower ones? So the lower ones, strangely enough, Albert Park, which is also quite a very good suburbs, that is also one of the lower ones. So in this way, in a very short plot, you can understand very easily the prices and the suburbs in a very concise and precise manner. The bar plot is perhaps one of the most important plots, and what it does is that it plots the categorical data, and the length of the plot is proportional to the values that they represent. For example, here we have the number of bedrooms in the house, and then we have which houses would have these type of bedrooms. So we see what is the most common type of houses. It is a 3-bedroom house, followed by a 4-bedroom house, and then the 2-bedroom house, and the 1-bedroom, and then the 5th bedroom is also there, 6th bedroom, and the first one, number 1, and the other bedrooms, which are very large houses in this data set, 7, 8, 9, I don't know, 33 bedrooms, very rare. So this is a data set which shows this kind of a plot. I sometimes like this type of plot, which is a bar plot, but what it has done is that it is plotted horizontally, and it is arranged in a descending order. So what happens when you see it? You see the top one at the first, and followed by the second top one. So you see here it plots the number of products in the data set, and here the Peter Pan creamy peanut butter, that is at the top one, followed by the raw oysters. So it gives a very easy way for the user to visualize, and for the reader to visualize very easily which one is the most occurring one. Before we go into the correlation, just a brief recap. What is correlation? So a correlation term is widely used to define the linear relationship between two normally distributed variables. A value of 1 represents a perfect positive relationship, -1 a negative relationship, and 0 indicates the absence of a relationship. So it is also given by the covariance of two variables x and y divided by the standard deviation of x by the standard deviation of y. Let's not to worry about the computation here. There is also a lecture in this playlist, in this channel, about covariance matrix, correlation. Please free to watch it later on. But I just wanted to give you a glimpse of the correlation, what it is, before we go into the correlation map. So this is a correlation map. So what it does is that which variables are correlated with which ones. So here, if you see, the more lighter it is, the more correlated it is. So price with price, obviously it would be 1, because the same variable is correlated the most. And then if you see the lighter ones, 0.7, and if you see what is 0.7, you go down here and you see price is highly correlated with square foot living. Then you go down here, 0.67. So if you go down here, so grade is highly correlated with price. Then 0.61. So square feet above is also highly correlated. Among the negative correlated ones, this one, which is a zip code. Okay, zip code is not a great thing to be correlated, but anyways, it is correlated in this manner. The less correlated ones are, say, what is this? Square foot lot. so it is less correlated with price. So the correlation map gives a very easy way to understand the correlation between various variables in a data set. So this completes our session on data visualization concepts. Hope you liked it. Bye.